Hi, I'm delighted to present our work in containers, privacy and data protection by runtime scanning methods. We are Francisco Rojo and Dr. Deakin. Our work consisted in developing a novel runtime software vulnerability scanning framework that uses software assertion techniques for Docker containers environments. It mainly drives privacy and data protection for containers environments as an active scanning method. Today, many organizations have adopted containers as a technology in their environments. These offer them large benefits in driving microservices architectures, rapid development, and ability to expedite their build in the software side. So, despite of these drivers, the key security issues prevail, which is the existence of vulnerabilities in the Docker container images, Docker host, and in its abstraction layer, and also Docker Hub as a repository for Docker public images offers 8 million images today, where back in our research in March 2021 there were 4 million images available. This is an increase of 100%. Our vulnerability scanning framework consists of 5 components. This is the core component, is technically the engine that runs Nmap in the scanner, and we also use a fetch module that will go and retrieve the CVEs related to Docker or related to our environment out into the NIST API. And then we have the runner component. It mainly takes care of the assertion techniques against each of the containers and validates the vulnerabilities in runtime. So this is an active component. And the callback, it's mainly to provide notification back to the requester. And the connection takes care of the connectivity from the framework to the host or to the containers. So we compare our framework with existing models in related literature. This is a highlight of findings, and we can see that the presented model offers scanning capability, defense capability, and runtime active software capability, despite other ones just covering 2 components. So we see that in our framework, DevOps teams are the key persona in acting for using this type of approaches. So in saying that, we can tell, well, DevOps teams will know what their environment is about and what images they're running, and they will technically go through bug scrub their CVEs and want to check this shortlist to validate okay with this. So this is the case. So we know we are running specific workloads, and we want to validate these specific CVEs in our environment. So the more we add to our library, the richer it becomes, and the accuracy factor of our results will also increase with the more tests we conduct. So we target these CVEs for these specific images like a Docker Docs, a HA proxy, containerd, and libcontainerd. So in this demo, we pretty much go through initially on the right side. We can see the fetcher script going and passing through the NIST API and getting some results. We can see that 159 CVEs were detected. We listed really 82 that relates to Docker or to our environment, so we can quickly have a look and see what's there. So it's a nice tool. There are some other equivalents out there, but yeah, just wanted to use that quickly. So technically now go into the core. So we check our container ID is that. So we, as highlighted, we run our runner, and it technically is gonna scan against that on that particular CVE. So our nmet NSE script detected that the assertion test passed, and we found that the criteria matched the blank password, and hence we consider this is vulnerable. So similarly, we now target our HA proxy workload and find a condition that as well passes and detects the CVE exposure in this container. So we can see that we technically are going through specific targeted CVEs in our container. So we can identify what could be a potential threat. So CVEs will classify these depending on the impact, exploitability score, and so on. So we pretty much are determining the grade listing or blacklisting of our containers based on the results of our tests. Please note that these containers are running, so these containers are active in the environment, so we're meant to run this actively. So it's not before the workloads are loaded. So here we just found that the lib container, the daemon, is running with some configs, the JSON files that are considered vulnerable as per that CVE. So we can act as per the advice of the CVEs, right? So that was the end of the demo, and we'll just go to the next slide here. So achievements of our work covered, well, this framework completed successfully runtime scanning methods for Docker host and containers environments. It has the ability to grade list and blacklist containers based on the attestation testing results. It's a lightweight scanning framework, so it's easily can be adopted by DevOps environments in DevOps teams, and really go with your DevSecOps strategy, right? So that's pretty much the aim. So the Novelty ran of research consisted in well, this is, we believe, is the first runtime vulnerability scanning framework for Docker containers environments, and its lightweight capability allows an easy adoption in DevOps teams. So that's highlights, and future work relates to implementing a trust model within the containers environment, also enablement of PKI, and incorporate additional CVEs or vulnerabilities into the library. So apart from running additional runtime scanning techniques in the container network on the CNI. These cover our work, and well, thank you very much, and have a good day.